the fourth video lecture of chapter 7, Acids, Bases and Salt, class 7th Science. Okay, so in this session we would be starting with detailed discussion regarding salts. Okay, till now what we have discussed is, in the first video lecture we looked into the introduction regarding acid, bases and salts. Okay, acid base indicators, what are they? We have already many times discussed that tasting the substance, whether it is sour or whether it is bitter, okay, whether it is salty, we cannot directly say that yes, this is salt, yes, it is tasting sour, therefore we can say it is acid, or if it is bitter in taste, so it is base. We cannot taste every substance. For that harmful wala thing, to overcome this, acid base indicators are used. What are the acid base indicators? Okay, what colors do they exhibit in acidic medium, in basic medium and in neutral medium, that we have already discussed. In the second video lecture we discussed in detail regarding acids. Okay, what are their properties, their physical properties, their chemical properties, their uses. Okay, similarly in the third video lecture we started discussing about bases in detail, which includes types of bases, although we have discussed types of acids in first video lecture also. Okay, similarly we discussed about the difference between strong acids and weak strong acids and strong bases, weak acids, weak bases. That means, what is the difference between strong and weak? Either it could be acids, either it could be bases. Okay, so in the third video lecture we discussed about types of bases, which says what are the different strong bases, what are the different weak bases. Then we discussed about the different properties of bases, like physical properties of bases, some where they are bitter in taste, whatever that we discussed in first video lecture, it sum up in physical properties. Then we started with chemical properties, their reactions with different with acids. Okay, in bases there was only one, that was reaction with acids. But in case if we talk about acids, so chemical properties of acids include reactions with metals, reactions with carbonates, okay, reactions with bases. So again, that were the chemical properties we discussed in acids. So you have to remember these reactions. With this, we are going to start today with the fourth video lecture, which provides you the detailed information regarding salts. Okay, here there are salts which are acidic in nature, which are neutral in nature, which are as well as basic in nature. Okay, you cannot say that salt is it is neutral. You cannot say like this. It depends if you are taking, suppose if you are taking how the salt is prepared. So we would be discussing that, but basically we prepare salt by adding acid or by reacting acid with base. By reacting acid with base, we get salt plus water plus evolution of heat. Okay, so when I say acid and base, so there are different cases. I would be taking, in first case, if I take a strong acid like HCl, and if I take a weak base, like calcium hydroxide, let's say calcium hydroxide. So if I take a weak base like calcium hydroxide and I make react with acid, strong acid, that is HCl, we would be getting something like calcium chloride, water along with heat. Okay, this triangle represents heat. Okay, so in the reaction you can write in the equation, while you are writing the reaction in the form of equation, you can represent this heat with this symbol triangle. Anyways, if we talk about calcium chloride, here calcium chloride is which salt? So you can say it is a calcium chloride is an acidic salt. Calcium chloride is an acidic salt. Why? Because in the formation of this calcium chloride with calcium hydroxide and hydrochloric acid, you have taken strong acid. You have taken strong acid. Okay, so therefore you are getting acidic salt. Let's suppose we take another example in which now you are using weak acid and strong base. So the salt you would be getting would be basic salt. Why? Because you are taking strong base to form that particular salt. Similarly, if you take, there is one another case, if you take both strong acid plus strong base, okay, the example for which we have discussed many a times, HCl plus NaOH. If you observe carefully, HCl, strong acid, NaOH, strong base, gives what? NaCl. So this time the salt form is neutral. Okay, so there are three different types of salt: acidic salt, basic salt and neutral salt. And how do we come to know that this particular salt is basic, acid or neutral? So it depends on its preparation. While preparing, whether we are taking strong acid, whether we are taking strong base, or whether we are taking both acid and base strong. Okay, so depending on that, there are three different types of salt. Okay, so with this, we would be starting discussing about, preparation of salt. So how salt is prepared. And as we have already discussed, that whenever I say salt, that doesn't mean that it is NaCl. No, NaCl salt, or it is also referred as common salt, that we use in our kitchens, in our food, okay, in preservatives. Okay, we would be discussing its uses also. So common salt is you can say is a salt, it's a type of salt. But apart from NaCl, there are many other salts. Okay, there are many other salts, like you can refer to the calcium chloride which we formed just now. Okay, apart from this, potassium nitrate, okay, sodium bicarbonate, sodium carbonate, okay, copper sulfate. These are some salts we would be discussing furthermore also. Okay, so there are different salts apart from sodium chloride. Sodium chloride is not only the salt. So remove this wrong psyche of saying that salt, that means NaCl. This is not the thing. There are different salts you can observe in your surroundings. Okay, without wasting much time, let us start with preparation of salts. First method for preparing salt is reaction between an acid and a base. So this we have discussed many a times, that when I made sodium hydroxide, again I would be saying you that while writing the chemical reaction, you make notice that you are writing the name of the compound just below it. Okay, so sodium hydroxide is made to react with hydrochloric acid, which forms sodium chloride, and sodium chloride is a neutral salt. Sodium chloride plus water. So this is one of the way, and this is also referred as neutralization reaction. It releases heat. Okay, so this is one of the way how you can prepare a salt. Another way is reaction between an acid and a metal. Reaction between an acid and a metal. Recall quickly, we have discussed in first video lecture, or else, if I am not wrong, second video lecture, wherein we discussed about acids. And if you recall, we discussed chemical properties of acids, wherein there was first chemical property which says reactions of acids with metals. Are you able to recall? Second video lecture, chemical properties of acid. First chemical property of acid saying that reactions of acids with metals. So wherein what was happening is, when I made react with acid with metal, what happens is metal would be replacing hydrogen from the acid. Okay, let us check this out. These were the two same examples as provided in the acids wala portion, which says that here there is metal which is magnesium. So this magnesium tries to replace the hydrogen present in acid, that is hydrochloric acid. So magnesium, which is a metal, tries to replace hydrogen of acid by itself. Okay, as I have discussed, it would be saying to the acid, let it's my time now, I would be joining with the chlorine. So magnesium chloride is formed along with evolution of hydrogen gas. Okay, so if I talk about magnesium chloride is an example of salt. So when an acid is made to react with metal, it results in the formation of salt along with the release of hydrogen gas. Another example we discussed, when zinc reacts with sulfuric acid, what happened? The zinc would be replacing the hydrogen and it would be attaching itself to the sulfate group, forming zinc sulfate. And this zinc sulfate is nothing but the salt. Okay, salt along with hydrogen gas evolution. Okay, moving down to next preparation. Next is reaction between vegetable oil and caustic soda. So remember, what caustic soda is common name of what? Caustic soda is common name of what? Either it is an acid or a base. Let me give you a hint. It is an base. So now you recall, if I talk about caustic soda, which base I am talking about? Which base is having its common name caustic soda? If you recall, you would be getting the answer as sodium hydroxide. So sodium hydroxide's common name is caustic soda. So when caustic soda reacts with vegetable oil, or you can replace it with animal fat. So either you use animal fat or oil with sodium hydroxide, you would be getting soap and glycerin. Now you would be thinking, man, the chapter is going regarding salts and you are talking about soaps. So you recall carefully, soaps are nothing but they are the sodium salts of acids. They are the sodium salts of acids. Soaps are nothing but salts of acids. That means acid is required to make the salt. And wherever in all the three cases you observe, the salt formation is taking place, the compound, the salt, is formed by replacing the hydrogen of an acid by a metal. So the metal is here, the sodium is the metal in case of soap. Here different metals are used, magnesium, zinc. Here sodium, see. Every base in here, okay, if I take another base like potassium hydroxide, so there also potassium, calcium hydroxide, again calcium is a metal. Okay, so every time formation of salt takes place by replacing the hydrogen of acid by a metal, and this metal comes from base. Okay, and there is one activity given, if I am not wrong, activity 6. Activity 6 is regarding the formation of soap, wherein you have been asked to take 20 ml of castor oil. You can replace the castor oil with coconut oil. Basically in activity 6 they are asking to make a soap at home. So you can make this by taking 20 ml of castor oil or coconut oil, and to it you add 20 ml of NaOH solution, that is sodium hydroxide solution, or you can say caustic soda. Okay, now this 20 ml of NaOH solution is prepared by, they have also said that you take 1 teaspoon of sodium hydroxide, okay, and to it add 20 ml of water, and to it add 20 ml of water. As a result you would be forming 20 ml of sodium hydroxide solution. When you make these two react by boiling, let it boil for 15 to 20 minutes. For 15 to 20 minutes the solution you would be getting would be containing soap. You can separate the soap from this solution by adding separation of soap adding salt. By adding salt. So when you would be adding, salt in this soap solution, what happens? There would be a formation of thin crust of soap on the solution. Let's suppose this is the soap solution. So after adding salt, what happens? There would be a thin, layer of soap is formed on the upper surface of the solution, and that is nothing but this is the soap. Okay, so this is how the way goes, that you take castor oil along with sodium hydroxide solution or any vegetable oil or any animal fat you take along with sodium hydroxide solution, and you boil it for 15 to 20 minutes. If I am not wrong, let me check it out. Yes, I thought that this is wrong range, but it is from 5 to 10 minutes. Okay, 5 to 10 minutes you boil it, and you would be getting then the solution that you would be getting would be containing soap, but you want to separate the soap from the solution. So you would be doing this by adding salt. While you are adding salt, okay, what happens is, as a result, after some time, the layer of soap would be floating over the surface of the solution, and then you can separate it out. The soap present in the solution, you can separate it out easily. Okay, so this is how what activity 6 says, and how soap is formed. And soap is nothing but the sodium salt of acid. So this is also one way of preparation of salt. Moving down to next topic, which talks about naming of salts. Now when I say salt, let us take an example of salt, which is sodium chloride. Very familiar salt. Very familiar salt if I talk about sodium chloride. So the sodium chloride is NaCl. Sodium chloride, NaCl. Common name is common salt. Okay. सोडियम क्लोराइड का कॉमन नेम क्या है? कॉमन सॉल्ट है. When I talk about salt, salt is made by acid and base. So it always comprises one component of acid and one component of base. The component of base, or the basic part, comprises the metallic part of salt. While the acidic part comprises the non-metallic part of salt. If you are in bit confusion, let us take an example. To form sodium chloride, what I do? I take NaOH and HCl. Here you observe there is base and there is acid. Okay, so when I get the salt, I get in the form of NaCl. That means there is sodium and there is chlorine. From where do I get the sodium? From base NaOH. So from base I am getting metal sodium, which is forming the metallic part of salt. From acid I am taking chlorine, because this metal is replacing this hydrogen. So the compound which is formed by replacing hydrogen of an acid by metal is known as salt. So the metallic portion we get from base, and the non-metallic portion like chlorine हो गया, sulfate हो गया, carbonate हो गया, bicarbonate हो गया, nitrate हो गया, many more. So these are nothing but non-metallic part which are obtained from acid. So here you see chlorine is a non-metallic part from acid. So this is how the naming is done. When acid is contributing to non-metallic part and base is contributing to metallic part, is always giving metal, until and unless there is an exception called ammonium salts. So for example, if in place of base, as I take NH4OH, okay, suppose NH4OH plus HCl, so it would result in the formation, this ammonium group, this is not a metal, this is ammonium group which we have already discussed. So this ammonium group replaces hydrogen and forms NH4Cl. Ammonium chloride is also a salt. So here you see base is contributing, apart from metal there is ammonium group. So usually base contributes metallic part in salt formation, but in case of, if I take ammonium base, okay, ammonium hydroxide, so their ammonium group would be replacing hydrogen and would be forming, now these two both are non-metallic parts. So this is an exception. Apart from this, acid forms the non-metallic part and base forms the metallic part of the salt. Okay, so we take few examples. Okay, so these examples are given in tabular form. So let us check it out one by one. Okay, so first example is given of Na2SO4. What would be the name of this salt? The name of this salt would be sodium sulfate. So while writing the name of salt, you first write the name of the metal, that is the metallic part, and then the non-metallic part. That means first you would be writing the name of the part which is derived from base. Okay, if I say in sodium sulfate, what is the metal? Is sodium, Na. What is the non-metallic part? Non-metallic part is sulfate, SO4. Okay, so that means metallic part, that means it is derived from base. तो ऐसा कौन सा बेस है जिसमें सोडियम होगा? It can be NaOH. ओके, और नॉन मेटेलिक पार्ट मतलब मैं एसिड की बात कर रही हूँ, तो एसिड का सल्फेट किससे आएगा? सल्फ्यूरिक एसिड. तो अगर मैं सल्फ्यूरिक एसिड के साथ NaOH लेती हूँ तो आई वुड बी राइटिंग सोडियम सल्फेट. सल्फ्यूरिक एसिड में से सल्फेट मिलेगा और NaOH में से मेटल सोडियम मिलेगा. इन दोनों को जोड़ के we get a salt which is known as sodium salt. Again, if you take an example of copper sulfate, okay, so here the metal is copper, the non-metallic part is sulfate. So we get the salt's name as copper sulfate. If you observe carefully, metal is derived from base. So let us take an example, suppose copper hydroxide, because usually hydroxides of metals or oxides of metals or carbonates of metals or bicarbonates of metal are examples of bases. Repeating again, hydroxides, oxides, bicarbonates and carbonates are the examples of bases. Okay, next, तो कॉपर हाइड्रोक्साइड एक बेस हो गया. सल्फेट जो है वो सल्फ्यूरिक एसिड से आता है. ओके, सिमिलरली कैल्शियम कार्बोनेट, मेटल इज कैल्शियम. ओके, कार्बोनेट CO3 is the non-metallic part. So this is derived from carbonic acid. Carbonic acid when reacts with the base containing calcium, we would be getting the salt name as calcium carbonate. So you have to always write first the name of the metal and then the non-metallic part which is derived from acid. Similarly, NH4Cl. Here NH4 is not acting as a metal but is acting as a group, ammonium group, along with chlorine. So chlorine would be derived from which acid? Can you guess? Yes ma'am, it's very easy, that is hydrochloric acid. Hydrochloric acid. Okay. So when ammonium group reacts with hydrochloric acid, it forms ammonium chloride. The salt name is ammonium chloride. So you have to first write the basic part, then the acidic part. Again, if I talk about KNO3, here the metal is potassium. Okay, and the non-metallic part is nitrate. So potassium nitrate. Potassium nitrate. Okay, again this is an extra example which is not in textbook. Why I have written here? Because see, suppose here if I talk about nitrate, from which acid it is derived? Nitric acid, HNO3. Okay, so before this table there is some information given which says that sulfates of salt come from sulfuric acid, carbonates of salt comes from carbonic acid, chlorides of salt comes from hydrochloric acid, nitrates of salts come from nitric acid. So they have given example of this, but they have not given the example of acetate. Okay, acetate. So here the metal is zinc. Okay, this is the acetate, that is CH3COOH. This is the CH3COO, okay, minus. This is derived from acetic acid. So whenever we talk about acetates, they are derived from acetic acid and leads to the formation of salt called zinc acetate. Okay, now these were all some examples and how the naming of salts can take place. Okay, if we talk about non-metallic part, from which salt, from which acid this non-metallic parts are derived, that we have discussed. So you have to remember that in case if the salt is containing sulfate, so which acid would be involved in forming the sulfate of that salt? That is sulfuric acid. Similarly, carbonate, carbonic acid, nitrate, nitric acid, chloride, hydrochloric acid, acetate, acetic acid. Okay, we moved on to next, properties. What are the properties of salts? Physical properties. Yes, this preparation means chemical properties. We are talking about physical properties. Salts generally are solids in state. Okay, solid in state. They have high, upward arrow here means high, M dot P, melting point, B dot P dot, boiling point. So they have high melting and boiling point. They are solid and they are soluble in water. Because they are soluble in water, they are good conductors of electricity. As I have discussed, the tap water can conduct electricity, but the water, distilled water, which is very purified, does not contain any other ion apart from hydrogen and oxygen. ठीक है, ऐसा पानी जिसमें कुछ भी नहीं है, salts नहीं है, distilled water है, वो distilled water electricity conduct नहीं कर पाएगा. But as in case if I take tap water would be able to conduct electricity because that would be containing salts. Yes, so since salts are easily soluble in water, salt solutions are very good conductors of electricity. Okay, these were few properties. We talk about uses. If we talk about uses, we start with first. This is NaCl. What is the name of this salt? Sodium chloride. What is the common name of this salt? Common salt. Okay, sodium chloride, common salt. What are the uses? They are used as preservatives for pickles and any other preservatives in food items, preservation of food items. If we talk about curing in meat and fishes, then there also salt is required. This common salt is required. This common salt is also required in manufacture of chemicals such as Na2CO3. What is Na2CO3? We have already discussed in bases. That is washing soda. And if I talk about NaHCO3, that is baking soda. So sodium chloride is used in preparation or manufacturing of baking soda, washing soda and NaOH. What is the common name of NaOH? Caustic soda. So caustic soda, baking soda and washing soda, बहुत soda है. So this NaCl is used to prepare these three sodas. Okay, move on to next. If we talk about NaHCO3, just now discuss. What is NaHCO3? Sodium bicarbonate. Sodium bicarbonate is a salt. We have already discussed in uses of bases where NaHCO3, that is nothing but baking soda, is also prepared by base NaOH. Okay, so with the help of bases we can form salt known as baking soda, and this baking soda is used in baking breads or cakes, in medicines and in fire extinguishers. So in class 8 you would be studying a chapter, if I am not wrong, regarding combustion and flame. So in that chapter we would be discussing about simple fire extinguishers where the sodium bicarbonate is used. Next, if we talk about potassium nitrate. So potassium nitrate is used in manufacture of gunpowder. Gunpowder is something which is also present in fireworks, in firecrackers, in explosives. So therein potassium nitrate is used. What is the common name of potassium nitrate? So it is nitre, N-I-T-R-E, nitre. Common name of sodium bicarbonate, baking soda. Common name of NaCl, common salt. Okay, next if we talk about what is the next use of potassium nitrate? That is in glass industry. So in manufacture of glass, potassium nitrate is required, which is a salt. If you talk about fertilizers, potassium nitrate is also used as a fertilizer. Okay, next is K2SO4, that is potassium sulfate dot Al2SO4 whole thrice aluminium sulfate dot 24H2O. This whole is a formula for potash alum, for potash alum. So potash alum is also a salt. Okay, and this potash alum is nothing but in layman language, or is the, what is the common name for this is fitkari. Okay, so you have all, in Gujarati it spells like fatakri. So this is used in purification of water. And how it is used, we have already studied in class 6. The chapter name is separation of substances, wherein how the fatakri or fitkari or potash alum is used in purification of water. The separation technique is loading. If you are not able to recall, flip the pages of class 6, or else you would be also discussing in detail regarding this in class 9th as well. Okay, now we talk about copper sulfate. Copper sulfate dot 5H2. This is used as, copper sulfate is known as, since 5H2 मतलब ये hydrated salt है. This salt contains water. Potassium sulfate K2SO4 dot Al2SO4 all twice dot 24H2. 24H2O, that means it is a hydrated salt. Okay, contains 24 molecules of water. Contains 5 molecules of water. Details regarding which you would be studying in higher standard, no need to worry now. But you should know that what this 5H2O means. That means the salt is hydrated. This contains water. Okay, so copper sulfate's common name is blue vitriol. So blue vitriol is used as a fungicide. Now if you check it out carefully, fungi or fungi, whatever you spell, fungicide or fungicide. So side means, any term ending with the suffix side, CIDE, that means to kill. So to kill fungi, copper sulfate is used. Electroplating is a part of metallurgy. Is a part of metallurgy where to separate metals, or to also not metallurgy, but we can say for coating. Suppose if I want to coat iron, this is an iron rod. If I want zinc on this iron rod, okay, so by electroplating I can you have heard about something known as jewelries. Okay, so these jewelries, artificial jewelries are also available in market. And you have also heard about that this artificial jewelry, ऐसा सुना होगा, ऐसा बोलते हैं कि सोने का पानी चढ़ाया हुआ है. This jewelry is not actually made up of gold, but इस पे सोने का पानी चढ़ाया. सोने का पानी चढ़ाया मतलब क्या, कि that means कि वो उस पे gold का coating किया है. ठीक है, that contains some coating of gold, and this is done by electroplating. Details regarding which again you would be studying in higher standards. So this copper sulfate is also used as in electroplating, as a fungicide, as in cleaning, sanitation and laundry, okay, and is used in textile industries. Apart from this, if we talk about silver nitrate, there is no common name given for silver nitrate, but its uses for developing films in photography. Okay, so if you are more interested in this uses, you can search on Google the details regarding which you would be getting, or you move further with suspense. In higher standards you would be cleared by some of the this methods like purification of water, electroplating, fungicide. Fungicides you would be again studying in class 8 first chapter, crop production, where along with this you would be studying about pesticides, insecticides. Okay, so these were all uses of salt. Lastly, the chapter is left with its effect, wherein it talks about NaCl, that is sodium chloride. It provides that this its effect gives that how NaCl is important for our body. Okay, NaCl is basically important in functioning of nerves and muscles of our body. Nerves and muscles of our body. Okay, so to also they have provided that while sweating we not only lose water, but along with this many vital salts. So sweating is good, but if you are over sweating, so to prevent dehydration, है ना, गर्मियों में होता है ना dehydration, तो dehydration को prevent करने के लिए the doctor suggest you to have water along with some salts. And have you heard about different brands such as Vital Z, okay, Electrolyte. So this Electrolyte and this Vital Z, there are some with other brands are also there. Many brands are there for which are acting as a to prevent this dehydration. We can have these, okay, the persons which are losing sweat, especially the sport person or the person who is doing intense exercise. So there are high chances of losing high amount of water in the form of sweat. So along with sweat, salts are also removed out, but salts are essential for working of nerves and muscles. So for that, to revive the salts which have been lost, we can use certain dehydrating or we can say hydrating agents to prevent dehydration. So some of the hydrating agents are electrolytes, Vital Zs, etc. There are many brands, as I already said. So this was the important fact. You have to you must read once in your textbook, and you must read once the whole chapter at least, I said. Okay, so I recommend you to read the chapter after seeing this video, because in this video I have covered all the things which is given in textbook almost. Okay, so if you feel like you are not able to getting a particular topic, or if you feel like I have skipped particular topic in the chapter, you can write in comment box directly, or you can send me a mail on the mail address given below in the description box. Okay, so this chapter from my side is at the end of, okay, at the verge of end. So that's all for this chapter, that is chapter 7, acid, bases and salt.